Good evening, all. I welcome you all for today's session, sine wave generators. So, in our waveform generated and voltage regulators unit, our third unit, we are running with our third unit. So, the first two topics we have already discussed in our previous sessions, like comparator and Shimmer trigger. Now, we are going to discuss about sine wave generators. Okay. So this circuit that is used to generate a sine wave, a circuit which is used to generate a sine wave is called a sine wave generator. This is one kind of waveform that appears from electricity outlets of home applicants. This waveform can be observed in AC power as well as applicable in elastics. We know that there are different type of waveforms that are generated by different electronic devices. So each waveform generates different sounds. A sine wave is one kind of signal that is utilized in acoustics. To design the sine wave generator circuit, there are different types of components required like an integrated circuit, resistors, capacitors, transistors, etc. So the working principle of the sine wave generators, or it is an outstanding tool. See, this is the symbol of sine. This is the product shown in the image is a sine wave generators. It's an outstanding tool to generate sine wave using wave drivers, otherwise campus. The frequency range of this generator will range from 1 Hz to 800 Hz, and the sine wave amplitude is to be changed. So we can notice the nature of quantum for standing wave models when the sine wave generator jumps from one resonant frequency to others. So the sine wave generator includes inbuilt memory that permits to find out the latest and temp frequencies for extra explorations. Okay. So the features of sine wave generator includes the following: the output frequency using the knobs like fine and coarse. The sine wave signal voltage can be changed by adjusting the voltage, and it has a main feature like a smart scan that allows the knobs for changing the frequency easily once turned continuously. The sine wave generator device, a plastic case mainly includes a rear rod clamp and angled rubber feet for the options of dynamic mounting. An inbuilt clamp is used to place this generator over a standard rod. In this generator, the frequency can be displayed digitally with the resolution 0.1 Hz using red color LEDs. This generator stores an increment of frequency and will rotate during the range of frequency using the recognized growth for adopted convenience. Okay, so these are all the features. And next, the sine wave generator, you can see in general we have discussed about the sine wave generator. So how the sine wave generator is executed using op-amp. The sine wave signal is used along with an arbitrary frequency, which is in different designs of circuit. So this is the circuit which can be designed with the dual op-amp, resistors and capacitors. You can see two op-amps here, op-amp 1 and op-amp 2, and a couple of resistances and capacitance are connected here. So this produces a sine wave by generating a square wave first at necessary frequency using an A1 amplifier. The connection of this amplifier can done like an adjustable multivibrator, and the frequency of this can be determined through the capacitor R1 and capacitor resistance R1 and capacitor C1. The two-pole low-pass filter using amplifier A2, it filters the output of the square wave signal from amplifier A1. So the cutoff frequency is equivalent to the frequency of square wave from amplifier A1. The square wave signal is made up of the basic frequency and the abnormal harmonics of the basic frequency. The most of the harmonic frequencies removed by the low pass filter, and the basic frequency remains at the output of the amplifier 2. So the square wave signal basics frequency component is 1.27 and the square wave signal's peak amplitude is the same. The output of the sine wave amplitude will be around 87% of the sine wave signal. The peak of this value will depend on the supply voltage of the amplifier as well as the output swing condition of the amplifier. Here the resistor values are 1 kilo ohms and this must be matched in the value to assist in minimizing errors during the operation of actual frequency as compared with the operation of calculated frequency, right? So these are all the features of sine wave generator, and you can see the following equations which are used for the component selection and which is necessary where the sine wave frequency is f, and the capacitor C1 value can be selected randomly and the component or calculated like the following equations which you can see here. C3 is equal to C1, C3 is equal to 2C1, then R1, R6, R5. These are the ranges of our capacitors. Okay. So this is all about our sine wave generator. Thank you.